Hi there. We'll continue with complex numbers. Here we ask to solve the equation to find x and y, x being the real part of this complex number and y being the imaginary part. So if we were to look at the right hand side and expand this, we'll have that 3 add I, 2 minus 3i is 3 2s are 6 minus 9i, add 2i minus 3i squared. Now 3i squared, I squared is minus 1, so this would be positive 3, a real number. Added to that we'll have 9, and minus 7i, minus 9i add 2i is minus 7i. So if we equate this, we have x at the left hand side is equal to 9 minus 7i, which we can clearly read off that x is equal to 9 and the imaginary part y is equal to negative 7. I'm Alistair. Thanks for watching. Right, here we have a fraction and we need to solve for x and y. So what we need to do is simplify this left hand side, and by doing that we'll be able to find our real and imaginary parts. But how do we do that? Well, we'll just realize the denominator by multiplying the top and the bottom of this fraction by the complex conjugate of the denominator. So that's 2 add 5i, multiply by 1 add I, and the denominator is 1 minus I times 1 add I. What do we get with this? We have, clearing the brackets, 2 add 2i, add 5i, add 5i squared. And this is 1 squared, which is 1, and minus I squared, which is also will give us 1, so we have 2 in the denominator. If we simplify the numerator, we have minus 3 add 7i over 2, which we can write as the real part minus 3 over 2 and the imaginary part 7 over 2. This real part minus 3 over 2 and the imaginary part 7 over 2, which gives us that x is equal to minus 3 over 2 and y is equal to 7 over 2. So we just kick this off by realizing the denominator, and that means to multiply the denominator by its complex conjugate and turn that into a real number, 2. Simplify the numerator and equate the left hand side or the right hand side to the left hand side, or the left hand side to the right hand side. Either way, x is equal to minus 3 over 2 and y is equal to 7 over 2. Thanks for watching. I'm Alistair. Here we have another one here. X add y I squared is equal to 3 add 4i. Well, the first thing that comes to mind is that the left hand side needs to be simplified in order for us to see what's going on, because it's a complex number squared. And if we close the brackets here, we have x squared, add 2 of the quantity of this times this, so it's 2x, y, we'll put I in brackets, outside brackets, and then we have the square of y will give us y squared, and I squared will give us -1, so that will make it minus y squared, and this is equal to 3 add 4i. Now we have the coefficient of I being 2xy, and the coefficient of I here is 4. Alternatively, we can say that 2xy is the imaginary part and 4 on the right hand side. So we can equate that 2xy is equal to 4. So the product xy must be equal to 4 divided by 2, which is 2. And x and y are both real. So real numbers that will give us a product that will give us 2. We have that x is equal to 1, y must be equal to 2, or we can have that x is equal to -1 and y is equal to -2. These are only solutions for real numbers. So first we clear the brackets, we end up with a quadratic in x and y. We equate the coefficient of I, or the imaginary part, to the imaginary part on the right hand side, which gives us 2xy is equal to 4, which is the same as xy is equal to 2. And for real number solutions, you can have x as 1, y as 2, or x is -1 and y is -2. Thanks for watching. I'm Alistair. Hi, another operation we have with complex numbers is multiplication. Here's an example. 3 add 4i, 5 minus I, to give us 3 5s are 15, minus 3i, add 20i, minus 4i squared, which gives us 15, add 17i, and this is minus 4 times minus 1, because I squared is -1, which gives us 20, add 17i. Another example is 3 add 4i, 3 minus 4i, gives us 9 minus 12i, add 12i, minus 16i squared, and this gives us 9 add 16, which is 25. In this last example, 3 add 4i times 3 minus 4i. 3 add 4i is a conjugate. So 3 add 4i is a conjugate of 3 minus 4i, and vice versa. 3 minus 4i, or 3 add 4i, is a conjugate of 3 minus 4i. And we can say that 3 add 4i and 3 minus 4i are conjugate complex numbers. Similar to something you've come across in algebra, where you have a add b times a minus b is equivalent to a squared minus b squared. And that's it on multiplication of complex numbers. I'm Alistair. Thanks for watching. Here's another. Find the square root of 15 add 8i. Well, we know that 15 add 8i, the square root of this is a square root of, a complex number, a add bi. We square both sides, we have 15 add 8i is equal to a squared, the square of a add bi, minus b squared add 2abi. Now ab is equal to half the coefficient of I, which is half of 8, is equal to 4. So possible values of a and b are -1, -4, and 4 and 1. And we can check this. You can write this as these as complex numbers. -1 minus 4i. We square that. We have 1 add 4i add 4i add 16i squared. And this I squared is -1, so this becomes -16. Add to 1 is -15. Add 8i. And the other is 4 add I squared, which gives us again 16 add 4i add 4i. This time adding I squared. I squared is -1, add to 16 will give us 15, and we have 8i. So the square root of 15 add 8i is 4 add I and -4 add I, which you can write as the square root of 15 add 8i equals plus or minus 4 add I. Please note that this will only work for integer values of a and b. Here we have the integers being 15 for a and 8 for b. Thanks for watching. I'm Alistair. Hello there. Here's another one. We need to find the square root of this complex number. We know the square root of 21 minus 20i is of the form of a complex number a add bi. This will only work for integer values for a and b. ab is half the coefficient of I. Coefficient of I is -20, so half of that is -10. And now we can write the possible values of a and b, because the product of a and b is -10. We can have 1 and -10, 10 and -1. We can have 5 and -2. 2 and negative 5. It's not possible to have or to choose these two. Well, it's possible you can choose them, but when we have checked them, they are not valid solutions. So these are the two valid solutions, and I'll show you why. I'll just check it. We have that 5 minus 2i squared is equal to 25 minus 10i minus 10i and 4i squared. So we have 4i squared. I squared is minus 1. This becomes minus 4. Add that to 25 will give us 21. And we have minus 20i. So that way we can see that these are two valid values for A and B. And next we'll check 2 and negative 5. So that's 2 minus 5i squared. And this will give us 4 minus 10i minus 10i at 25i squared. I squared is minus 1, so this becomes minus 25. Add that to 4 will give us negative 21. And we have minus 20i. We can write this as minus 21 at 20i. And so our square root of 21 minus 20i, at least one of them, is what we have is 5 minus 2i, and the other 2 minus 5i. We can write this neatly as plus or minus 5 minus 2i as our square root. Again, only work for integer values for A and B. Thanks for watching. I'm Alistair.